Hi everyone. How many four-digit even numbers greater than 5,000 can be formed from the digits 4, 5, 6, 7, 8, 9 if no repetition is allowed? So this is without repetition. All right. We have four digits. We're going to use this fundamental counting principle. And so we need the four digits. 1, 2, 3, 4. And here are numbers. 4, 5, 6, 7, 8, and 9 that we can use. Now, the first thing we have to do is look at the greater than 5,000. So basically, we can start with 5 because any of these numbers without repetition, if you start with 5, are going to be greater than 5,000, right? Because there's no zeros here. So if there were zeros in repetition, you would have to reconsider it. But so we can use 5, 6, 7, 8, and 9. So basically, since I have 5 choices, and I'm just playing around with this right now, I'm going to write 5 of these. So they can either start with 5, 6, 7, 8, or 9. So here's our possibilities. So I can start with 5, 6, 7, 8, or 9. That means for our first digit, we have one choice here, one choice here, one choice here, one choice here, and one choice here. Now the reason I'm doing it this way is because we have to look at the four-digit even numbers. So basically, if we, how many even numbers? If for it to be an even number, we have to have an even number in the last digit. So that would be 4, 6, or 8. All right. So for the first one, if it starts with 5, and we can't use repetition, we have 3 choices here. All right. Now for the 6, if my first digit is a 6, then I can't use this one again. So I only have 2 choices to use. So I'm going to have to put a 2 here. For the 7, I still have the 3 choices because 7 is not even. So that's going to be 3. For the 8, that means we would use the 8. That means I only have 4 and 6 I could use. So that's only 2 ways. And then for the 9, that's not even, so we had 3. All right. Now that's the part we need. Now there's no repetition. So basically, with what we have here, we have used 2 digits. We have a total of 6 numbers. So whatever digits you used here, we have subtracted 2 numbers that we can't use anymore. So we only have 4 numbers left. So all you do with the middle terms is you're going to write 4 times 3, 4 times 3, 4 times 3, 4 times 3, 4 times 3. All right, that's one way to do this. And then what I'm going to do is look at the ones that are in common. So what we have in common. Now this was just the digits we were looking at for the first digit. But this is what we have. So basically I have 1, 2, 3 of these. So I have 3 of these 1 times 4 times 3 times 3. Or you could just say this is 3 times 4 times 3 times 3. Because we don't really need to put that 1 there. All right, so, and then we have 2 that look this way. These are the same. So this would be 2 times 4 times 3 times 3. So in other words, we could have done this from the beginning, but it's 3 times 2, sorry. Put a 2 here. We have 2 of those. And the way you want to look at it is you want to say, well, you can get this kind here. So this is going to equal, I just did 3 times that. So 3 times 36, that gives you 108. Or you could have gotten this set. This set would have been 2 times 24. That's how I did it. You could just multiply it through, and that's 48. Since you're using the word or, that means you're adding these two. Right? You either can get this kind, where the first digit's odd, or this kind where the first digit's even. So you just add these two numbers up and you're going to get 156 4-digit even numbers can be formed. And that's your final answer. Thank you. Have a nice day. Bye-bye.